we are going to take a look at simplifying with square roots a little bit more. Here are 3 examples from the past, so if you want to refresh your memory, you can push pause and look those over. These are the examples we're going to look at. In mathematics, it's not proper to have a square root in a denominator. So there is a method that we just call rationalizing these square roots. So I'm going to show you in these 3 examples how we're going to eliminate having a square root in the denominator. In my first example, I have a square root of 7 in the bottom. If I were to multiply another square root of 7 to the bottom, that would become a square root of 49, and the square root of 49 equals the nice whole number 7. Now I am permitted to multiply square root of 7 to the bottom of that fraction, as long as I multiply square root of 7 to the top as well. And the reason that's permitted is the square root of 7 divided by square root of 7 equals the number 1. So if I multiply 1 to anything, it doesn't change the value of that number. So as long as I'm using the same thing in the top as the bottom, it won't alter its value. So now the next thing I need to do is just multiply in the numerator. And the 5 and 7 can't be multiplied together because the 5's not under a square root symbol. So my final simplified answer for the first one would be 5 square roots of 7 over the number 7. In my second example, in the denominator, there's an additional coefficient of 3 being multiplied by the square root. We're not going to worry about the 3. It's only the square root that we need to worry about. So I want to multiply square root of 6 to the bottom, but once again I have to do that to the top as well, so I don't change the value of my original fraction. Now I'm going to multiply the top together, which is 2 square roots of 6. In the denominator, it would actually be 3 times square root of 36. The square root of 36 is actually a whole number, so in my denominator, it's the same thing as taking 3 times the whole number 6, which is just 18. So I'm going to change that to an 18. Now as I look at my fraction, my 2 and 18 are not under square roots. I can reduce those. So that means I would have square root of 6 over 9 as my final simplified answer. You cannot reduce the 6 and 9. One of them is under a square root, but the other one is not. Okay, my third example, I have a square root of 2 in the bottom. So I'm going to multiply square root of 2 to the bottom as well as to the top. Now this time in my numerator, I can multiply the 5 and 2 because they're both under square roots. In my denominator, that would be the square root of 4. And the square root of 4 equals the whole number 2. So there's my simplified answers for those 3 examples. Okay, let's take a look at this example. The only thing I don't want to have in the denominator is that square root of 3. So I'm going to multiply square root of 3 over square root of 3 to the complete fraction. In my numerator, the 5 and 3 can actually be multiplied. In the denominator, that's the same thing as 2 times the square root of 9. So once again, I'm going to simplify that denominator. Square root of 9 is the whole number 3, so 2 times 3 is 6. And then last, my 4 and 6 also reduce, so I'm going to reduce both of those by 2. So there's my final simplified answer. In my last example, this one's a little bit different than the others because it's 2 separate terms in the denominator. It's 3 plus a negative 6. So I can't just multiply a negative 6 to the denominator. If you have a binomial in the bottom of your fraction, we're going to use something that's called a conjugate. here's what my conjugate would be for this example. The only thing that changes is the sign in between the two terms. I'm not changing the first three to be a negative. I'm only changing the sign in between the two. Now, as in the past with the other examples, whatever I multiply to the bottom, I also have to multiply to the top. So now let's take a look at the top of this. When I multiply these terms together, I'm actually using the distributive property. I need to multiply 4 to both of these. So 4 times 3 is 12. 4 times square root of 6 remains as 4 square roots of 6. The 4 is not under square root, so I can't multiply it directly to the 6. Okay, my denominator. I have two terms. I'm actually going to use the FOIL method. So for our denominator, we have to FOIL. So my first terms would be 3 times 3. Next, I'm going to go back and take 3 times that negative square roots of 6. Now I'm going to go to the inside terms, so square root of 6 times this 3 would be a positive 3 square roots of 6. And then my last terms, a positive times a negative, I would have a negative, and it's square root of 36. Now as I look in the denominator, I do have two like terms, and they're actually opposites, so those two add out to 0. So in the denominator, I really have a 9 minus, and my square root of 36 equals the whole number 6. That means my new denominator would just be the whole number 3. And I'm just going to bring the numerator down in front. And I'm just going to walk through one more using the conjugate. There's two terms in the bottom, so I would need to multiply 2 plus square roots of 3 to the top and bottom both. In my numerator, it is the distributive property. So my first two multiplied together, the 5 and 2 can be multiplied. The 2 just remains under the square root. Then I'm going to go back and distribute with the others. The 2 and the 3 can be multiplied this time because they're both under the square root. My denominator, I have to FOIL, so I'm going to start by multiplying the first terms, 2 times 2. My outside terms would be a positive 2 square roots of 3. The inside terms multiplied is a negative 2 square roots of 3. And my last terms would be a negative square root of 9. Okay, so my numerator. I'm just going to bring my numerator down. The denominator, I have two terms that add out to 0. So actually I'm left with 4 minus 3 because the square root of 9 equals 3. And 4 minus 3 equals 1, so I'm going to change that to a 1. And I can also do this. Since my denominator is 1, it's the same as that. So my simplified answer for this example would be 10 square roots of 2 plus 5 square roots of 6.